Okay, hello everyone. We're here with the 2017 AP number 4. I'm going to take a quick peek at the question, and I see it up there. It looks like a, once I see the word boiled potato, and it's on a pot, and it's either cooling or heating, I know I'm probably dealing with one of two types of problems. Either a piece kitty problem, or a piece kitten problem. Piece kitties are the one where the rate is directly proportional to the quantity. They usually start out like this. They look like dy dx, or the dp dt equals kp. And piece kittens are one that start out as dp dt equals k times the difference between two things. Usually x minus 40 or x minus something, depending on a temperature difference or something like that. So I haven't looked at the problem yet. We're going to take a look now and see which one this is. Boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees at time t equals 0. And the internal of the potato is greater than 27 degrees Celsius for all times where t is greater than 0. So basically it means to take the potato out of the oven. It's going to reduce down to room temperature. Room temperature is 27 degrees Celsius. So there's always going to be a difference between those two numbers right there. The internal temperature of the potato can be modeled as a function h that satisfies the following differential equation. dh dt equals negative 1/4 h minus 27, where h of t is in degrees Celsius. And they gave me the initial condition again. Oh, that's in red. Hold on. Undo. Red. Okay, so let's see our first question. Write an equation for the line tangent to the graph at that particular value. So, oh, and I need a tangent line. Line equals, get your derivative, your cross-country team, and forget you. So I'm writing down the original equation that we have, but I'm going to translate it to the letters that we are using up here. So we've got L equals, the graph of H would be H prime. Oh, let's write it as H prime. I like that better. H prime of what value? They want it at 0. H prime at 0. X minus 0. And the value of H at 0. Okay, so we're going to find it at 0. So my line is going to be, L is equal to, H prime of 0 would be, H prime is dh dt. Okay, at time 0. So that would be equal to negative 1/4, whatever the temperature is at time 0, which is 91, minus 27. So L is equal to, I don't necessarily have to simplify it, but I know that 91 minus 27 is 64, and 1/4 of 64 is 16, so h prime of 0 is negative 16. Okay, now let's go ahead and write down x is x minus 0. If you don't want to write the 0, you don't have to. And we need h of 0, so I need the temperature at t equals 0, which is 91. So there's my linear equation. Now they asked me to use that line to estimate the temperature of the potato at time 3. So H at 3 is approximately L at 3, which I'll fill in as negative 16 times 3 plus 91. I'm not even going to put those numbers together because that's enough for that answer right there. First thing was the equation for the tangent line, which is right here. And the second part is the equation of the using the line to estimate temperature at time 3. We have that part right there. Now they asked me to use d squared h over dt squared to determine whether my answer is an underestimate or an overestimate. Okay, well let's see. So if I know dh dt equals negative 1/4 h minus 27, I'm going to find the derivative of that function. Now, if you don't like it in this format and you want to distribute to begin with, negative 1/4 h plus 1/4 times 27. So that means that the second derivative, d squared h over dt squared, you don't have to do this both ways, you could have done it either way. I'm going to show both though. So for the first one, it would be negative 1/4 times the derivative of h, which is dh dt. And the derivative of 27, negative 27 is a constant that goes away. A constant on the outside multiplied on the outside just continues into its next derivative. Or if I simplify it to this, I would get d squared h over dt squared equals negative 1/4 dh dt. Okay, so they want me to see if what the answer is for the problem before this. I want to find d squared h dt at time t equals 0. D squared h dt squared at time 0 is going to be negative 1/4 times negative 16. I don't care what the number is because that answer is positive. That means that the graph itself is concave up. So I'm going to draw a curve here. And I'm going to sketch a tangent line on a graph that's concave up. So the tangent line is separate from the curve. Okay, so we used the tangent line to estimate the value at 3, which would be on this side of the graph right here. So the graph would be an underestimate. Underestimate. And the reasoning for the underestimate, you can go CPIC, or you can say because the graph is concave up. And they've given me a different equation. It says for t less than 10, there's an alternate model for the temperature of the potato. So my pocket rocket I was wrong on, or my piece kitten or piece kitty, where G is measured in degrees Celsius, and G of 0 still equals 91. Finds an expression for G of t. So I'm solving this differential equation for G of t. So I'm getting all the G's on one side and dG's and all the T's on the other side. I'm going to do this in one step. I'm going to move dt to the other side. And then I'm going to bring this to the other side with a negative exponent. So it's going to be negative G minus 27 to the negative 2/3 dg equals dt. So now I am ready to integrate both sides. That's a highlighter. That's not going to work, Ethan. Can't use a highlighter. There we go. So I'm going to integrate this side. I'm going to integrate that side. And I'm going to end up with, okay, so this is going to go up to the 1/3 power. There's a negative sign there, a flip of that out there, negative 3/2. G minus 27 equals T plus C. So now I'm going to cancel those out right there. So now I've got to get the G by itself. So the first thing is multiply each side by 2/3. It distracted me while I was taking this integral, and I messed up. I obviously got this to the correct power, but it shouldn't have been a 2/3 on the outside. It should have been the flip of 1/3, which is 3. Come on, Mike. Okay, so now I'm going to multiply both sides by 1/3 to get that to go away. So I've got G minus 27 to the 1/3 equals 1/3 T plus C. You can leave it like that. To get this by itself, I'm going to cube it. Give myself some more room. Okay, so I get G minus 27 equals 1/3 T plus C to the 3rd minus 27. Oh, add 27. Michael, keep messing me up. So I moved that over there. That is the general solution because I didn't figure out what C is. Now, how am I going to figure out C? Well, I'm going to write it down separately. I'm not going to fill it into the equation. I'm going to say that C at t equals 0, G was, can't see it, hold on, 91. So I'm going to fill those numbers into the equation. So we've got 91 equals, parentheses, 1/3 c cubed plus 27. So I'm going to subtract 27, bring it to the side. Then I'm going to put that to the 1/3 power. And then I'm going to multiply it by 3 to give me c.